11 आज पढ़वा केमिकल प्रॉपर्टीज ऑफ फिनॉल केमिकल प्रॉपर्टीज फिजिकल प्रॉपर्टीज होतिला आज पढ़वा केमिकल प्रॉपर्टीज केमिकल प्रॉपर्टीज ऑफ फिनॉल पढ़वा केमिकल प्रॉपर्टीज ऑफ फिनॉल फास्ट हमरा आसीबो एसिडिटी ऑफ फिनॉल एसिडिटी ऑफ फिनॉल एसिडिटी ऑफ फिनॉल परीक्षा रे क्वेश्चन आसे बहुत समय हाई फिनॉल इज एसिडिक बाय एसिडिटी ऑफ फिनॉल फिनॉल ले OH ग्रुप रहउची कि सेटा एसिड जनरल हम जानि जे कंपाउंड कंटेनिंग OH ग्रुप्स आर बेस सोडियम हाइड्रोक्साइड पोटेशियम हाइड्रोक्साइड और alkali base or alkali but here OH group is directly linked to nuclear substituted benzene phenol is a nuclear substituted compound here OH group is directly attached to benzene तो सेठी OH टा जो लागु OH टा हम थिको से बेस होबा कथा नई काहे सेटा एसिडिक होछि कथा कहू a substance is said to be acidic nature if it releases a proton in presence of water the substance water presence से तो H+ आयन बाहर था ताला में हमको RNA theory तक हमें एसिड कहना phenol when dissolved in water produces phenoxide ion and a proton. It is your phenol. When phenol dissolves in water, it ionizes to produce phenoxide ion. It is your phenoxide ion plus a proton. And proton is released during this process. It is your phenoxide ion. Phenoxide ion. Phenol. When phenol is dissolved in water, it produces phenoxide ion and proton. As proton is released during this process, so phenol is said to be acidic in nature. Moreover, phenoxide ion is stabilized due to resonance. Phenoxide ion, it is your phenoxide ion. It is your phenoxide ion. It is your phenoxide ion. Here it carries negative charge. When this negative charge comes to this position, a double bond is formed here. As a result, this bond will shift this position. As a result, resonance operate, which can be represented through double-headed arrow mark. Now, this becomes after resonance, a double bond is formed due to resonance. A double bond is formed in between benzene and oxygen atom, and a negative charge is created here. Now, as it is negative charge, this part should be positive one, as this should be shift, electron should shift like this position. As a result, it will becomes double bond O. A double bond is formed. As it is negative charge, it will becomes positive. Minus plus indicates a double bond. A negative charge comes to this point. This place, as a result, a double bond is present also here. Here this bond will shift to this position. As a result, resonance further operates to form compounds like this. Here double bond will form at this position and negative charge will come to this end. Now further resonance operate. As a result, this double bond will come to this end. As a result, electron pair will shift this position and a positive charge is created here. As a result, a double bond is formed in between this position. So this can be represented like this. So due to resonance, position of double bond shifts from, suppose it is your structure 1, it is your structure 2, it is your structure 3, it is your structure 4, it is your structure 5. Suppose for phenol, considering phenol molecule is represented like this. It is your phenol molecule. Which, as you know that a lone pair of electron present over the oxygen atom. When this lone pair electron comes to this, as a result, a double bond will form at this position, and oxygen atom will carry positive charge, and this double bond will shift this position. As a result, resonance operate. Resonance is nothing but the distribution of the electron over the same atomic skeleton. Only distribution of electron takes place. As a result, a double bond is formed in between OH benzene ring and OH group where oxygen atom carries positive charge and a negative charge is created at this position. Now this double bond electron shift this position. As a result, here a positive charge is created. As a result, a double bond is formed in between these two positions. So for further resonance, which is represented through double-headed iron mark. Now this figure becomes it is a double bond OH single plus. Here it is minus, and this position will become positive. As a result, minus and positive plus indicates a double bond. Here a negative charge comes to this end. Now this double bond polarized to this position. As a result, a positive charge is created here. Minus plus indicates the presence of double bond. So further resonance operate. As a result, now double bond OH single plus, and here a double bond is formed and negative charge comes to this end. Now this double bond comes to this end. As a result, this plus when the electron class move to this position, plus when combined with minus neutralization occurs. As a result, it only becomes single bond OH, a double bond is formed here, another double bond is formed here, another double bond is formed here. So due to resonance, more number of resonating structures are possible when phenol ionization it forms phenoxide ion. For the phenoxide ion is more stable due to more number of resonating structures. As you know that more is the resonating structure, more is the resonating structure of an acid, more will be its acidic character. हमें जानू छे जे एसिड रे रेजोनेंस ऑपरेट करे ता पय जो अधिक गुडे स्ट्रक्चर लिखि होता है ता लस जगह एसिड रो कैरेक्टर बढ़िबो फॉर फेनोक्साइड आयन 1 2 3 4 5 structures are possible, or 5 canonical structures or resonance hybrid of 5 structures are possible. So for phenoxide ion, due to resonance a double bond is formed between oxygen atom and benzene. Here no charge separation occurs. So as more number of resonating structures are possible for a phenoxide ion, but in case of phenol, the charge separation occurs. Here a single molecule contains dual charge. One is positive charge, other is negative charge. Due to charge separation, a double bond is formed in between oxygen atom and benzene. As a result, here oxygen atom carries a positive charge, for which removal of proton will be difficult. For this reason, phenol is less acidic as compared. So phenol is less acidic. Phenol will less acidic than phenoxide ion. Phenoxide ion is more stable than phenol, or more acidic than phenol due to more number of resonating structures. But in case of phenol, charge separation occurs. That means a positive charge and a negative charge. Both each structures contain both positive and negative charge. Due to charge separation, a double bond is formed between OH group and benzene, for which removal of proton will be difficult task for phenol, but which will be more easier due to after the removal of the H plus ion, phenoxide ion is formed from phenol. For the phenoxide ion is more stabilized due to more number of resonating structures. As you know that more is the resonating structure of an acid, more will be the acidic character of a compound. So phenol is acidic, or phenoxide ion is more acidic than phenol. Therefore, the effect of substituent. The phenol सहित हमरो को सब्स्टिट्यूएंट थिले प्लस आई ग्रुप बा माइनस आई ग्रुप मनको यदि प्लस आई ग्रुप थाए प्लस आई ग्रुप गोटे होती प्लस आई ग्रुप आ गोटे होती माइनस आई ग्रुप प्लस आई ग्रुप माने इलेक्ट्रॉन donating group by electron donating group by electron releasing group तक पाया जाए माइनस आई ग्रुप माने इलेक्ट्रॉन अट्रैक्टिंग ग्रुप एगड़ा इलेक्ट्रॉन देबे एगड़ा इलेक्ट्रॉन निजार टाणी देबे तो प्लस आई ग्रुप जदी था इलेक्ट्रॉन डोनेट करू था तार इलेक्ट्रॉन डेंसिटी विल इंक्रीजेस ओवर द ऑक्सीजन एटम as a result the removal of the phenol tomar ko C6H5OH the ionized color of phenol side ion C6H5O minus plus H plus ion the plus I group rahi tha that will electron donating group is electron donating group as a result the electron density over the oxygen atom will increase for which removal of proton will be difficult which indicates the decrease in the acidic character of phenol. So presence of plus I group, presence of plus I group that is electron donating group decreases acid strength due to accumulation of negative charge over phenoxide ion for which removal of proton will be difficult will be a difficult task कौन हम जानिले ना जदि प्लस आई ग्रुप लागि थाए बेंजीन की ताले सेटा इलेक्ट्रॉन डोनेट करिवो जा फल रे नेगेटिव चार्ज फेनोक्साइड ऊपर जति रहिबा कथा और इंटेंसिफाइड हे दिबो एक्युमुलेट हे दिबो से बढ़ी दिबो यदि नेगेटिव चार्ज फेनोक्साइड ऊपर आयन ऊपर बढ़ी जाए प्रोटॉन जो रिप्लेस होगा कथा बाहर का कथा करू प्रोटॉन आयन जो बाहर जा प्रोटॉन बाहर करिवो डिक्रीज हे दिबो so accumulation of negative charge over peroxide ion for which removal of proton will be difficult task which decreases the acid strength so the minus I group tha electron attracting group minus I group will attract the electron towards itself as a result the negative charge which is created over the peroxide ion decreases and the negative charge decreases or diminishes over the peroxide ion removal of proton will be easier so presence of plus minus I group increases acid strength similarly presence of minus I group increases acid strength due to electron withdrawing effect so this is about your effect of substituent on phenol then if phenol molecule contains a plus I group then its acidic character will decrease if it contains a minus I group then its acidic character will increase तापर पढिबा esterification reaction बा esterification esterification माने preparation of ester as phenol is acidic हम जानि जे गोटे एसिड गोटे बेस रिएक्शन करले एसिड कार्बोक्सिलिक एसिड when reacts with an alcohol in presence of a mineral acid then an ester is formed and the process is called esterification ethi when phenol reacts with acid chloride in presence of aqueous alkali kon kahili when phenol reacts with acid chloride in presence of aqueous alkali in the presence of, when phenol reacts with acyl chloride in the presence of aqueous alkali, then phenyl ester is formed. Then phenyl ester is formed, and this process is known as esterification. Phenol reacts with acyl chloride. Actually, in first step, phenol reacts with alkali to form alkali. Suppose if you take sodium hydroxide, when phenol reacts with the aqueous sodium hydroxide, then sodium phenoxide ion is formed. Then at second step, sodium phenoxide reacts with acyl chloride to form phenyl ester, and the process is called esterification. Phenol is your C6H5OH. It is your phenol. It is your phenol C6H5OH. It is your phenol OH. When phenol reacts in first step, phenol reacts with aqueous alkali, sodium hydroxide, NaOH aqueous sodium hydroxide to form sodium phenoxide and a water molecule. Sodium phenoxide and water. It is your sodium phenoxide. It is from sodium phenoxide plus water. It is your sodium phenoxide. Sodium phenoxide. In first step, phenol reacts with an alkali. You may take sodium carbonate here. Aqueous sodium carbonate. Then sodium phenoxide is formed. In second step, sodium phenoxide. It is your sodium phenoxide. When sodium phenoxide reacts with acyl chloride, suppose you take acetyl chloride, which can be represented as Ca3COCl. It is your acetyl chloride. When sodium phenoxide reacts with acetyl chloride, then NaCl is replaced. As a result, an ester is formed. It will be OCOCH3 plus NaCl. It is your Ca3CO acetate, phenyl acetate, phenyl ester. It is your phenyl acetate. If you take benzoyl chloride, suppose in place of acetyl chloride, if you take benzoyl chloride, it is your sodium phenoxide. When sodium phenoxide is treated with benzoyl chloride, your ClCO6H5. C6H5 become represent like this. Then NaCl is replaced. As a result, it is your benzoyl chloride, BnZOIl, benzoyl chloride. It is your acetyl chloride. It is your benzoyl chloride. Then it contains OCO. It is your phenyl benzoate. Phenyl benzoate ester, and this process is called esterification. Well, introduction of acetyl group. Acetyl group, that means CH3CO. Introduction of acetyl group in phenol forming an ester is called acetylation, ACETYLATI, and introduction of benzoyl group C6H5CO group is called benzylation. Acetylation means when your orthohydroxybenzoic acid, or it is benzoic acid, orthohydroxybenzoic acid, or salicylic acid. It is your salicylic acid when treated with acetic anhydride. Acetic anhydride is your Ca3CO2, acetic anhydride, in presence of mineral acid H plus, then an ester is formed. It is your COH. It will become ester COCA3, OCOCA3 plus Ca3COH plus acetic acid is your CH3COH. It is your acetyl salicylic acid, acetyl salicylic acid, which is otherwise known as aspirin, ASPRIN. It is a valuable analgesic. Aspirin, generally APC tablets are known as analgesic. Aspirin, P stands for phenacetin, C stands for caffeine. Aspirin, phenacetin and caffeine. These are the examples of non-narcotics analgesics. Or analgesic means painkiller medicine. Valuable painkiller medicine. Aspirin can be prepared by the acetylation of salicylic acid. It is your salicylic acid. Salicylic acid means ortho-hydroxybenzoic acid. Here acetylation due to acidity oil, salicylic acid is treated with acetic anhydride in presence of mineral acid. Then acetyl salicylic acid is formed, which is otherwise known as aspirin. And generally aspirin is used as a painkiller or known as analgesic. So this is about the esterification reaction. Then go to the electrophilic substitution reaction. 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 This is the formula, general formula of phenol. The C6H5OH can be represented like this. Here OH group is an ortho-para-directing group. It is an ortho-para-directing group because due to resonance, negative charge is created at ortho and para position. So OH group is an ortho-para-directing group. So an electrophile, as negative charge is created at ortho and para position, so an electrophile or electron-loving substances can easily attack or easily attach to ortho and para position as compared to OH group. OH group जो जगह रही देखो OH group टे resonance पाई ortho position रे ए जगह ortho position एटा होची para position एठी बा एठी ए जगह नेगेटिव चार्ज क्रिएट हो नेगेटिव चार्ज क्रिएट हो माने इलेक्ट्रोफिलिक माने इलेक्ट्रोफाइल माने इलेक्ट्रो लविंग सब्सटेंसेस से जगह से लागि परिबो तो एठी बा एठी लागि परिबो ऑर्थो पोजीशन रे लागि परिबो बा ऑर्थो बा पारा पोजीशन लागि मेटार लागिबो नाही तो इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन सब जगह ऑर्थो पोजीशन रे बा पारा पोजीशन रे हो मेटा पोजीशन हेबो नाही आगे पढिबा ब्रोमिनेशन हालोजिनेशन रे आगे आसो ब्रोमिनेशन माने एडिशन ऑफ ब्रोमीन when phenol reacts with bromine bromine से रिएक्शन कले कोन हबो दुईटा रिएक्शन ओटा phenol तमरो bromine से रिएक्शन करिवो aqueous bromine से रिएक्शन करिवो आ गोटे खाली ब्रोमीन से रिएक्शन करिवो आ ब्रोमीन से खाली जतो रिएक्शन करदिवो सेतरे कार्बन डाइसल्फाइड बा क्लोरोफॉर्म प्रेजेंस CH प्रेजेंस रिएक्शन करे अलग रिएक्शन when bromine reacts with when phenol reacts with the aqueous bromine or excess amount of bromine then 2,4,6 tribromophenolic bond eta tomar phenol so aqueous bromine reaction karibo bromine aqueous aqueous bromine se reaction kala tinita bromine molecule se reaction karibo ethi gote lagibo koitheli ethi gote bromine lagibo ethi gote bromine lagibo tala tinita bromine lagila na tinita bromine lagila ethi gote OH thila एठी गोटे ब्रोमीन लागला ऑर्थो पोजीशन रे एठी आ गोटे ब्रोमीन लागला आ गोटे ऑर्थो पोजीशन रे आ गोटे पारा पोजीशन रे लागला तो एठी तीनटा लागला तीन गुणे 6टा ब्रोमीन अछि तीनटा ब्रोमीन ला तीनटा ब्रोमीन तीनटा H वाला तीनटा H तीनटा ब्रोमीन मिसी कि 3HBl ताला आनाला 2 4 6 ट्राइब्रोमोफेनॉल 2,4,6 ट्राइब्रोमो फिनल जदि से फिनल दा एक नंबर कंडीशन 2 नंबर का एक्सेस अमाउंट ब्रोमीन सहित रिएक्शन करूची when phenol reacts with limited supply of bromine in presence of carbon disulfide or with chloroform then mixture of ortho and para-bromophenol is formed is a phenol जदि ब्रोमीन सहित रिएक्शन करूथाय लिमिटेड एक्सेस अमाउंट अछि in presence of carbon disulfide or chloroform CHCl3 कोन हबो ऑर्थो रे ब्रोमीन लागिबो बा पारा लागिबो मिक्सचर ऑफ ऑर्थोब्रोमोफेनॉल एटा ऑर्थोब्रोमोफेनॉल बा पाराब्रोमोफेनॉल हबो मिक्सचर ऑफ ऑर्थो बा पाराब्रोमोफेनॉल हबो एटा तो ऑर्थोब्रोमोफेनॉल एटा तुमरो पाराब्रोमोफेनॉल एटा तुमरो फिनॉल दिस इज रिगार्डिंग योर ब्रोमिनेशन तापर पडिबा सल्फोनेशन बी रे पडिबा सल्फोनेशन फास्ट ब्रोमिनेशन कहली तापर सल्फोनेशन माने फिनॉल सहित कंसंट्रेटेड सल्फ्यूरिक एसिड रिएक्शन करबो when phenol reacts with concentrated sulfuric acid then orthohydroxy benzene sulfonic acid is mixture of ortho and para-hydroxy benzene sulfonic acid is formed at low temperature ortho product is the major product but at higher temperature of 100 degree centigrade para product predominates over the ortho product and या कहली phenols of मोर एटा phenols sulfuric acid reaction करियो माने concentrated sulfuric acid H2SO4 reaction करे बोले कोन अब सल्फोनिक एसिड ग्रुप लागियो SO3H ग्रुप लागियो ऑर्थो पोजीशन रे बा पारा पोजीशन रे एटा तो फिनॉल एटा होची सल्फोनिक एसिड ग्रुप होची SO3H एटा ऑर्थो रे लागिला एटा ही पारे बा पारा रे लागियो पारा माने 1,4 पोजीशन एटा 1,2 पोजीशन पारा आला माने एटा SO3H एटा सल्फोनिक एसिड ऑर्थो रे ओएच लागिची ऑर्थोहाइड्रोक्सी बेंजीन सल्फोनिक एसिड बेंजीन सल्फोनिक एसिड ऑर्थोहाइड्रोक्सी बेंजीन सल्फोनिक एसिड एटा तोर पाराहाइड्रोक्सी बेंजीन सल्फोनिक एसिड एटा तोर फिनॉल at low temperature दुटा कंडीशन अछि the low temperature रिएक्शन करा जाउथि at low temperature ortho product predominates over para product but at 100 degree centigrade तापमात्रा 100 डिग्री होता है but at 100 degree centigrade para product is the major product माने या जदि रिएक्शन लो टेंपरेचर रे करा जाउथा है से जगह ऑर्थो प्रोडक्ट बारिबो एटा बारिबो बेसी परिमाण रो एटा बारिबो कम परिमाण रो बारिबो जदि टेंपरेचर 100 डिग्री रे देई जाउथिबो ताले पारा प्रोडक्ट बेसी होबो ऑर्थो प्रोडक्ट